This lesson will guide you through how to graph a system of linear inequalities. So we have already learned how to graph systems of linear equations, but this time we're going to be doing inequalities, which is these little guys, these signs, less than, greater than. So how does that work? And last quarter we learned how to graph just a single linear inequality with the shading on the left or on the right of the line or above it or below it. This time we're going to go over how to do it with systems of equations. So 3 steps are there. Graph the lines, but step 1 is if it's not in slope-intercept form, convert it to y equals mx plus b. Second, you graph the 2 lines. These are 2 skills you've already mastered. And in this lesson, I'm not going to go over those 2 steps. I'm just going to go over the last piece, which is decide which region should be shaded by checking with a test point. So just to recap, in the past, we graphed a line. Sometimes it was a solid line, and sometimes it was a broken line. And then we either shaded above it, that region, or we shaded the region below it based on the less than and greater than symbols. This time we're going to be doing the same idea. Now we're adding a second line, and we end up with 4 regions. And one of the 4 regions, the 4 spots here, is shaded. So it can be this region here or any of the other ones. So we have to decide which of the 4 regions, if we have 2 lines, gets shaded. And we are going to be doing this via a test point. So if the test point we choose is in the region and holds true, then that's the area we're going to graph. So let's go ahead and see how this looks. So let's look at number 1. So the lines have already been graphed. I'm sure you can do that on your own if you had to. Now we're just going to decide which of the 4 regions, so again we have that tiny one up here as well, is going to be graphed. So easiest way is to pick a test point on the x-axis or on the y-axis because that usually has a 0 on it, and it makes it a lot easier. So just looking at it, we have a total of 4 regions, and we have to see which region is the one that holds true. Now we can just ask ourselves, I'm going to shade below it, I'm going to shade above it, and then pick between 2 regions based off of 1 line. So I'm going to just go off the first line, which is y greater than or equal to x plus 3, which is this line right here. So based off of that line right there, I have the inequality greater than or equal to, which means I'm going to be shading above this line. So it's either region 1 here or little tiny region 2 there. It's not going to be the bottom 2 because this first inequality tells me it's shading above. So I'm going to do a test point on one of those 2 regions. So I'm going to choose a point anywhere I want on that region and substitute it into both inequalities and see for which one it holds true. So I'm going to go ahead and do that. So I am going to pick the point, let's say, -5, 0. That's going to be my test point. And if it holds true, then region 1 gets shaded. If it's false, then region 2 gets shaded. So I'm going to go ahead and start plugging that in. So remember, this is my x, this is my y. So first equation 0, greater than or equal to -5 plus 3. This one should automatically be true because of the shading we did earlier. So 0 is greater than -2. It holds for the first equation. Now we're going to plug it into the second equation. 0 less than or equal to 7 times -5 minus 3. That's going to be 0 less than or equal to -35 minus 3 is -38. So is 0 less than -38? This is a false statement, which means region 1, which is where the point I chose is located, is not the solution. Therefore, region 2 is going to be my set of points. So it's going to be right here. So you're just going to shade this little region right here. Again, this region actually continues if you extend the lines, which will make it a very large region. But in the graph we are given, we just see a tiny little part of it. So we're just going to shade this little section right here. All right, so that's our solution for the first one. Any point on this region will be our solution, including points on the 2 lines because both lines are solid. Let's go ahead and do number 2 now. Let's look at our 2 lines. I'm going to start with the first one. So -8x minus 4, which is the one that starts down here. So it's this line right here. So this line right here is the one we're going to decide on the left side of this or on the right side. So since this is a greater than sign, we are going to be shading above this line. If it's difficult for you to tell which side is above on this line, you can always go to the other one. It might be actually a little easier to tell on the second one. So I'll just go off the second one. So this is this line right here. So this has a greater than sign. That means we're going to be shading above this line, which would be these two regions up here, which is that tiny one again and the one on the right. So we have two regions from which to pick, region 1 and region 2. So we're going to pick a test point. I'm going to pick any point in this location. Again, you can pick, like, again, 5, 0. We can pick 0, 5, 4, 0. So again, I'm choosing numbers on the axis because they're easier to work with, but you can totally pick any point you want, like 4, 1. But 0 is nicer to work with, so I'm going to pick, I'll just go with this one, 5, 0. So I'm going to plug in 5, 0. If it holds true for both equations, then that's my region to shade, number 2. If not, I'm going to shade region 1, which is a small one. So I'm going to go ahead and plug that in. So 0 greater than, let's change this real quick. All right, 0 greater than or equal to -8 times 5 minus 4. So that's going to be -40 minus 4, which gives me -44. And 0 is definitely greater than -44. So it works for the first equation. Now we're going to check it for the second equation. 0 greater than -5 plus 3. And that gives me -2. So 0 is definitely greater than -2. Therefore, the region I am going to be shading is where my point is located, which is this section right here. So final answer is all points in this area, including the two solid lines. So let's move on to the next problem. Let me clear this out. And we're going to move on to 3 and 4. All right, let's go ahead and get started on this one. So I'm going to be picking my region that I'm going to be shading. So let's start with one of the lines. Let's start with the first one right here. So this line is the one that hits at 4, so it would be this line right here. And this is a less than or equal to sign, which means my shaded region will be everything down here. So again, one more time, this is a line, so it's going to be either region 1 or region 2 where the final shading is going to be at, because it says to shade only below this line. I'm going to pick a test point in this area. Let's go ahead and pick, I'm just going to pick 1, 0. Seems like, actually, let's go with 0, 0. It's actually going to be easier to plug that one in. So I'm going to go with the origin. That should be your go-to point if you can't use it. All right, I'm going to plug in 0 less than 0 plus 4. And 0 is less than 4, so it's true for the first equation. 0 less than -0 plus 2. -0 does nothing, and that's also going to be true. So both equations or inequalities are satisfied by the point 0, 0. So my answer is going to be shade anything in here. So let's actually go with the lighter color because it looks not so nice. All right, so anything that's in this area here is your solution. So any point here is a solution, including the two lines. Let's go ahead and move on to number 4. And let's see where we can start. We have two parallel lines because their slopes are equal. Therefore, I'm going to start with the first one right here. That's the one that hits the y-axis at -2, which would be this line right here. And this has a less than or equal to sign, which means it's anything below this line, which would be this. This is an area that's below, and there's only one region here. So let's check a test point. If it's true, that will be my answer. If it's false, then I would probably get no solution. So let's go ahead and see and pick any point in this region. I'll call it 1. Let's pick point, let's go with -2, 0. Let's go with a smaller number. And as we plug it in, it should work out. If it's true, it's my solution. So plug in 0 less than -2 times 2 minus 2. That's going to give me -4 minus 2, which gives me -6. And 0 is not less than or equal to -6. This is false. There's no point in checking because that means the only area where we had solutions is not going to work out. You plug in a point, let's say here, you're also going to get a false because it needs to satisfy the first one. Any point here will also be false. So in this case, my answer is no solution. Another way of seeing it, for the first one, this was the region. For the second equation, this is greater than, would be this area. They don't intersect, so that's why we have no solution. Let's go ahead and move on to the last problem. So this last problem is a taste of the types of equations where we really use this in real world problems. Let's say these equations came from trying to optimize the cost of something, and I'm not giving you guys the whole type of problem, but you will see these in Algebra 2. But here we're going to graph 5 lines and see where the shaded region is going to end up. So let's go ahead and graph these. I'll start off by switching both the first and the second equation to slope-intercept form. So first one, we're going to subtract 2y on both sides to get the y by itself. So we have y less than or equal to negative 2x plus 12. Go ahead and graph the second one. Same idea. X minus 4y less than or equal to negative 3. We're going to subtract x. So negative 4y less than or equal to negative x minus 3. In this case, we have to divide everything by negative 4. Since I'm dividing by a negative, my inequality changes. There's an invisible 1 on this x, so it's negative 1/4. Negative 1 over negative 4, which is positive 1/4 x, and positive 3/4. All right, and then we're going to go ahead and start graphing these lines. There's going to be 4 of them. Got to be very careful as we graph these not to make any errors. So let's go ahead and get started on it. I'm going to start at, let's say, let me see. I'm going to actually move my x and y axis a little bit just so I can have room going backwards. So I'm going to put them at 3 over. So I'm going to make this my x-axis. And I'm going to make this my y-axis, just in case they don't fit. Now I'm going to go ahead and graph the first equation. I'm going to start at 12. So this is 2. I'm just going to count by 2. 2 is 4, 6, 8, 10, and 12. So I'm going to put a point right here. Let's change the color. Let's go with purple. No, let's go with red. So that's going to go right there. And I'm going to go down 2 over 1 and graph my line. All right. Now, I'm not going to go into the negatives in this one. We're just going to, no, actually we can. Let's go for it since there's no restriction. So we connect the line for the first equation. Let's go ahead and graph the line for the second one. We're going to start at 3/4 on the y-axis. But again, since we have a fraction, we may want to choose other points. I'm going to do a quick t-table. I'm going to choose a point at 4 because of the fractions of 4. So I plug in a 4. I'm going to get 1/4 times 4 plus 3/4. And that should give me, actually that's not going to work out as nicely. Let's try 1 just so we can add the fractions. 1. So I'm going to plug in 1. So it's going to be 1/4 plus 3/4. Yeah, that should work out. That's going to give me 4 over 4. Which gives me 1. So there's a point at 1, 1. So I'm going to put a point right there. And I'm going to use, from this point, use my slope of 1/4. So I'm going to go up 1 over 4. Lands it right here on top. Up 1 over 4. It's right there. I'm going to go backwards. Down 1, back 4. Should be at the very edge. And these should be enough points to get my line going. And let's go ahead and graph the last 3 lines. Next line is y less than or greater than x plus 0, not 1, 0. So that's going to just be a line going upward at a 45-degree angle. So next line will be at 0. Up 1 over 1, it hits it right there. Up 1 over 1. So we keep on going. Up 1 over 1. And I'll stop putting points there. Get the idea. So let's go ahead and connect this line. And that didn't come out very nicely. Let's just stop there. You can see where they're crossing at this point. And the last 2 lines would be x is greater than 0. This line right here would be a vertical line because it starts with x at the number 0. So it would be right on top of the y-axis. And the last line is y is greater than or equal to 0, and that's going to be a horizontal line on top of the x-axis. So here are all my lines. Now we're going to go ahead and use our inequalities to see which region is going to be the shaded region. So I'm going to start with the first line, which is this one right here, and that's below that line, and that first line was this one right here. So we're going to do everything below that line, so it's going to be anything to the left, which is going to be this region here. But we have a whole bunch of little regions in that section. We have, let's go ahead and count them. We have, let me change the color. We have one region here, 2, 3, 4, 5, 6, 7. We have a whole bunch of them. So let's actually try to eliminate some of those regions by using one of our other lines and see where that tells us we should be shading. So let's go ahead and look at our second line, which is this one. And it's this one right here. This says greater than, so it's anything above it. So below this one and above that one, that cuts us down to this area right here. And that area right there appears to have 1, 2, 3 sections. So we're just going to go ahead and see which region works out. So I'm guessing that my solution is going to be in this general vicinity. So again, I have regions 1, 2, and 3 here. And those are the only 3 regions that we should be shading. I'm going to go with the triangle, just like it seems to be the most plausible one. So I'm going to graph the point 1, 2, 3, 4, 3. I'm going to go with the point 4, 3. And we're going to check that point. It should work out for all the equations. So 2 times 4 plus 3 less than 12. That's going to be 8 plus 3 is 11. 11 is less than 12. Works out. We try the next one. 4 minus 4 times 3 less than negative 3. It's 4 minus 12 is going to be negative 8. And negative 8 is less than negative 3. For the next equation, y is 3 is less than 4. That's also true. For the following one, 4 is greater than 0 and 3 are both greater than 0. So based off my assumption that it's in the triangle, final answer is shaded area will be inside that triangular shape. All right, go ahead and start the practice problems. Good luck.